Hello everyone. This will be the last video for chapter 8 and it's going to be on representing data. Or rather, it's going to be mostly about interpreting different presentations of data. Most of this is just going to be practice because they're diagrams you've seen before, bar charts, pie charts, etc. And you're just going to practice with getting the information from those. The one topic that I will be discussing in this video is the one new type of chart that is going to come up, and this is called a scatter graph. Now, before I get into those scatter graphs, let's see why they are useful. Scatter graphs in particular are useful to find correlations between two different variables. What is a correlation? A correlation is basically any connection between two variables. For instance, we know there's a correlation between exposure to sun and skin cancer. And in this case, we even know that this is a causation. We know that exposure to sun causes skin cancer. But a correlation can be weaker than that. It's already a correlation if they just happen at the same time. For instance, there's a correlation between shark attacks and ice cream sales. Not because one causes the other, but just because they seem to happen at the same time. Really, the cause for both of them is nice weather. But yeah, any of those correlations, those relations between two variables, that is what scatter graphs show very nicely. So what are those? Suppose you want to know whether there's a correlation between people's length, how tall people are, and how well they do in maths. So you do a survey, you ask people for their height, you ask people for their grades, and you have a wealth of data. Now you can try to put this in bar charts, pie charts, but it's kind of hard to compare the two. So what you're going to do instead with a scatter graph is you actually make a type of graph with the grade on the one axis and the height on the other. And, well, let's say the grades fit in like that, and anywhere from 140 to whatever length people are. And you put all the data in. Maybe someone is 150 and they had a 7. Someone else is 160 and they had a 5. And you put it in. What you might notice in this case is probably the data is going to come up all over the place, and there doesn't seem to be any sort of pattern to it because, well, height doesn't affect your math grade. So there is no pattern here. Maybe you see more people are tall, more people are short, more people have a low grade or a high grade, but we don't see any correlation. But this is the idea of this graph. Now let's have a look at a graph where there is a correlation. And as an example, I have this one. Here they are looking for a correlation between the age of a husband and the age of their wife in a heterosexual marriage. And we see that they kind of seem to cluster around this line here. Sure, there's some extremes where this doesn't work, but generally everything is kind of close. Well, can't draw it exactly, but kind of to this line over here. And if this happens, if we can kind of draw a line through all the data, you don't have to be very precise, but then there is a correlation. Then we can say, in this case, the older the husband, the older the wife generally, which, let's be honest, makes sense. And we can look at some of the extreme cases which do not fit the line very well. In this case, this person has, here we have a wife that is a lot older than the husband. The other way around, here we have a husband that's much older than the wife. That is the idea of scatter graphs. Here we have a direct correlation because the line goes up in both directions, in both x and y. You may also see a scatter graph that goes this direction, and then we have an inverse correlation where if one gets higher, the other becomes lower. You will see examples of both of these in the exercises. I'm not going to go any deeper into this, but this is your introduction into scatter graphs, and I wish you good luck working with these.